Good evening, ladies and gentlemen. Welcome to the fifth public lecture organized by Building Service Engineering Sectional Committee. I'm Dilan Tilanga, task leader for public lectures, Building Service Engineering Sectional Committee. Title today we are going to discuss is Building Management Systems, Essential Asset for Modern Buildings. I believe many of in this audience is aware about the term BMS or Building Management System. So it is so common in all the modern buildings around us. However, this is a refreshing field. The technology that you saw yesterday may not be the best practice for next generation. So it's always useful to learn new things, especially to learn unknowns of a known field. Further, this is the era of moving into green buildings. So if you have a BMS in your building, it has tendency to earn lot of points or credits specified by certified organizations. So it's an added advantage. So we discussed these things during last Techno as well. So we believe this is the right time to discuss about a topic like this. To do that, we have two foreign gentlemen in this audience. So it's a great privilege to appreciate them. And one of our presenters is Mr. Ian Giles, who has a master degree in management. He has worked in building automation industry for 25 years. Further, he has involved in advanced open protocol communication and integration technology to effectively operate and interact with buildings, to increase the efficiency of buildings, to generate and provide more information about buildings, and to reduce the amount of natural resources required to operate buildings. So this is the betterment of the world and the benefit of the people. Our other resource person is Mr. Jacob Sang. He has a bachelor degree in electrical and electronics engineering. He has worked in the integrated building automation industry for 23 years and currently works for Reliable Controls Corporation. I forgot to mention our previous gentleman is from the same corporation, Reliable Controls Corporation. Before that, Mr. Jacob has worked with leading BMS manufacturers such as Johnson Controls, Schneider Electric and Honeywell. He is constantly encouraging end users for energy efficiency processes to reduce energy and works towards green buildings. So this is the background of the lecture and the presenters. So it's my time to hand over this stage for these two gentlemen. The lecture will be started by Mr. Jacob Sang. Afterward, Mr. Ian Giles will taking over. So, ladies and gentlemen, please welcome on stage Mr. Ian Giles and Mr. Jacob Sang.
Okay, hi everybody. All right, so I'll be doing my presentations. You can stop me anytime you want. Ask questions. It'll be good at two-way dialogues itself. All right, thank you. So I'm talking about the revolutions of BAS. Okay, in the 1880s itself, the concept of installations of thermostats in buildings was introduced, where bimetal rooms thermostats is used to control temperature. And in the 1990s, mechanical, electronics, pneumatics control systems were developed as a primary control systems for environment in commercial building. It was really the introductions of computers that allows centralized automation control systems into a single building automation systems. That is in the 1980s. Okay. Computer systems itself is integrated with HVAC, heating, ventilation, air conditions itself. That was the primary roles of BMS. And other important automated systems itself is soon added to the computers itself so that they can communicate together, like fire alarm systems, lightings, and plumbing and sanitary itself. The multiple systems are integrated so the information will flow amongst them and they can be controlled and integrated. The architecture itself is not very fault tolerant. Why? Because when a computer stops or there's a break in the communications itself, the whole control system stops. That was when, to prevent such failure of systems itself, it will be the introductions of DDC happens. Sorry, pardon me, because I'm looking here and the slides is different, right? Okay, so in the 1980s itself, to prevent the failure of system, introductions of DDC controls was developed. DDC controllers become smaller, more powerful, reliable. Building automations become more distributed with DDC controllers spreads through how the whole building is where and when there's some things to control and monitor. Nowadays, the best practice measures is to locate the intelligence DDC controller physically at the equipment that is being controlled. Within this architecture, a single complications or computer failure itself has much less effect on the computer, on the BMS system. These controllers itself are built in with processors, RAMs, real-time clock, and web-enabled. It has its own programs and sequence of operations and has the capability of standing alone until the central communications is restored. In the year 2000 itself, almost all the ELV systems have high-level interface protocol like BATnet, Modbus, and OPC. We integrate these third-party systems call it IBMS, Integrated Building and Management System. Nowadays, every mechanical and electrical devices in the buildings comes with its own built-in microprocessor. It's ideally that building owners would like to integrate all these third-party devices to the BMS system. The problem is all these third-party devices itself have their own company being manufacturing their own different protocols. So to resolve this problem, we need to have a common language for all the devices. So we come up with BATnet, Modbus, or OPC protocol. From this architecture, you can see the fire alarm system, power meters, VSD, lift systems are controlled and monitored via high-level interface like BATnet, Modbus, OPC, etc. Just one pair of cables itself, you daisy chain them, you can control and monitor hundreds of points itself, compared to the conventional ways where each individual points itself you have to lay one pair of cables. In IBMS terms, integrations means connection various building systems together so that information can be shared between them and the operators. The benefits of doing that itself, the operators only needs to learn one software and maintain one machines compared to learn different softwares and maintaining different computers itself. BMS can access to the internet nowadays where you connect remotely. You can do controls, monitors, you can update synchronized timing, you can control through apps. Okay, you have apps phones itself, and in the event of alarms itself, it can be notifications by phones or email. Okay, I will give you some examples of integrations itself between different systems. security and BMS integration system. So how do you do integrations for security and BMS? So Mr. A is coming to the office itself. He taps on the reader with his card. His credentials itself allows him to enter the office. The door opens. At the same time, the card access controllers communicates to the DDC controllers via BACnet. Informing the DDC controllers that Mr. A is coming to work in the office. We will switch on the common corridors lightings and air conditions, and also Mr. A's work desk lighting. So while Mr. A is approaching to his workstation itself, the DDC controllers will turn on the plugs for his workstation. So Mr. A is So Mr. A is ready to work. So the card access system itself is intelligent enough to have people counting. So there's one person now in the office. He's also reading the CO2 with 235 ppm. And Mr. B is coming to the office. Same, he taps on the card. His workstation lighting is 100%. At the same time, the common corridors area itself become brighter, 80%, and the plugs itself is switched on. So people counting 2 CO2 ppm increase to 358. So when Mr. C is coming to office to work, same, the lighting and the plugs is switched on. As more people is coming in, previously it was 25 degrees. We lower down the temperature set points itself to 24, and we have increased our airflow. So people counting is 3, CO2 now is 752. This is not very healthy itself for the environment to work. So we switch on the fresh air damper to 18% to reduce the CO2. As the CO2 reduced to 515, the fresh air damper decreases to 10%. So the environment itself is good. I mean, enough oxygens, everything with ventilations wise is all good to work. And Mr. Manager is coming to the office to work. He tap on a card. He's going to his room. He tap on another card. Card access controller talk to the DDC again to set his desired set point for the lightings and aircon. 85% and 24.5. So now we are 4 person in the office, 515 ppm. So normally, end of the day, I think this is very common in worldwide offices itself. When people leave the office, nobody switch off the lights and aircons, plugs. They just leave it on 24 hours up to the next day where they are coming back to work. So they are wasting a lot of energy. So with the people counting itself, staff leaving the office. So with only one gentleman in the office now, when he leaves, okay. So now we have one, people counting is 1. With this gentleman leaving the office now, he tap on the reader. All the plugs is all off. The manager's aircons and air conditions and lightings is off. When he leaves the office, the common area will switch off. This is fully integrated through security and BMS. So I have another example. If let's say it's an office building where the landlord has his own security system and the tenant itself has his own BMS systems, we can do integrations on that. So when I come in to work, I tap on the card, on the turnstile, it talks to the DDC controllers, it talks to the card access controllers itself, the flaps open. At the same time, the card access controllers talks to the DDC via BACnet itself. So when I'm on my way to the lift, the lightings and the aircons is switched on based on my desired set point itself. So when I reach my office, everything is ready for me to work. As I leave the building, I tap on the building landlord turnstile. communicate with the card access controllers, with the DDC controllers, everything will be switched off. So we are even integrating with the landlord's card access controller with my BMS system in my office itself. So this is integrations to save energy. So in the late 2000s itself, we are moving from integrated building management system to intelligent building management system. So what is intelligent building management system? Nowadays everybody is talking about analysis. Okay. So I have integrated fault detections and diagnostic systems. So aircon is blowing, just imagine that aircon is blowing to this auditorium, everybody feels comfortable. But what is the back end, the AHU, air handling units, the fan coils itself? What is this going on over there? Nobody knows itself. With integrated fault detections and diagnostic systems, it helps end users, customers, building owners itself to have pre-empt notifications itself that there will be concerns within their equipments. So this will extend the lifespans of their equipments and you can save energy. So how does it work? We base on NIST standard, National Institute of Standard and Technologies. We write rules. Right, sorry, it's a bit out now. We write rules, tasks, and checklists that is editable based on the end user's building requirement. So changes can be made even after installations, after implementing the IFDD. You can make changes due to the environment changes itself. So these are some of the examples that air handling units, economizers, VAV box. Red colors indicates that there's a warning within the systems itself. Orange is indications that there's warning, but someone is already working on it. Green colors means that the system is healthy. So these are some examples of the rules that we can write based on NIST. And each rules itself, there is checklists for engineers, technicians, or even building owners to check every single point and rectify what is the concerns itself with their equipment. So I need to emphasize AHU is still working. Blower is still blowing. Your valve actuator is still opening. Modulating, the chill water is still flowing through. You still have comfort within the system, but there's something wrong within the systems itself. All right. So this is a schematic with 3 IFDD in place. So this will be another layout itself with the AHUs. I have 5 numbers of IFDD in place. This empowers the building operators with identifications and resolve fault, sub-optimized performance of equipment, improving life cycle costs, control occupants' safety and comfort, less emergency costs and support costs, and create the culture of accountability itself. So I like this the best. The reason is why all buildings owners, technicians, and engineers itself, they will create accountability. Why do I say that itself? Before you have IFDD in place in the BMS systems, operators just basically command start-stop, changing of schedule, changing of set points, viewing and monitor the trendings. That's about it. You know, look at it, no alarms, everything is good. With IFDDs itself in place, any abnormal within the systems, your equipment itself, there's warning. Engineers itself and technicians itself will learn. If I'm a new technician or engineer being employed by an owner itself, I do not know what to do. But with the help of the checklist itself, the technicians, engineers itself will learn from that and will improve their skill set. That's why it's create a culture of accountability. So I'm giving you another examples itself, IFDD. Right, I can write rules for AHUs, for example. Supply air temperatures for the AHU itself greater than 16.5, you will create a warning. So currently the supply air temperature is at 18 degrees. So for the green color flex tiles, we call this flex tiles, will turn to red. So I'm a building technician. What do? I do not know how to check. But with the assistance of the checklist itself, I click on the flex style. The checklist appear. Alright. So these are some examples of the checklist itself. It's a temperature sensors 40. You need this software offsetting, or you need to change the sensors. Is the living temperature for the chilled water too high? That causes the supply air temperature to increase. So if let's say that's the case, the chiller is having some problem itself. If the valve position closed for the AHU, someone manually override it, or does someone change the set point itself? Is the VFD running at lower speed? That means maybe the VFD is not working fine, or somebody changed the speed itself. Is the AHU switch off? Or even is the AHU timing belt loose or broken? We are not only looking on the conventional things on the BMS anymore. We are also looking at mechanical. So as a building technician itself, I know what to check. So after checking all these points physically on site, I will rectify the problem. The supply air temperature will be lower than 16.5. Right. So I have another checklist itself. Is the AHU filter dirty? The blocks the airflow itself. That's why the supply air temperature increase. So I have another IFDD rules. If let's say you have power meters on your AHUs that you are monitoring the running amp itself, and normal condition is running at 20 amps. I can set rules that if the AHU's running amp is greater than 23 amperes, you create a fault or a warning itself. It's not a fault, it's a warning. So currently my AHU motor is running at 25 amp. So what will be the conditions? Right? Change the rate. I'm a technician, I click on the rate styles. The checklist appear. It's a power meter 40. It's the AHU motor wiring due to unbalanced load. It's the AHU motor shaft out of alignment that causes frictions itself, causes high amperes. It's the AHU bearing 40, no greasing, no maintenance. It's the AHU timing belt too tight. Okay, without the IFDD, if your AHU is running on 25 amps, what will happen to your motor? Any guesses? Alright, your AHU motor itself will burn out. Alright, burn out, worst case, you change the model. But what if it doesn't only burns out, it caught fire? Your building will be on fire. So that's why IFDD also take care of safety and comfort of your tenants. Intelligent IBMS itself, we also need to have energy management reports. As building owners, always likes to know itself what is the usage within the energy usage in this building, which department is using the most energy, and how can you reduce energy usage. The solution is energy management report. Extract intelligence from your building data and discover actionable insights to improve operational efficiency. Pinpoint and rank wise and perform. Convert balancing opportunity to support your continuous optimized strategy. Energy management reports brings clarity to the building performance with reliable and rational analytics. This report itself can be delivered automatically by emails or diary. We can map it up through the BMS system. The other features of intelligence is we call this ranking component. So what is ranking component? If you have 1,000 fan coils in your building, what do? Normally you just get your technicians itself to do a routine servicing. Today I will do a servicing of number 1 to number 10, servicing of a fan coil. Tomorrow I will do from 11 to 20, and the following day 21 to 30, and it goes on. But with the ranking components itself, the building owners can have the rights to know the least efficient stand numbers of fan coils by verifying the fan coils valve actuator opening at over 90% for the last 3 months based on hours, the least efficient. So with these ranking components itself, I do not need my technicians to do routine servicing anymore. He will be proactive to rectify the concerns fan coils itself. So how does the technicians verify the reports? The technicians can gather all the data from the BMS through Diagnostic, data, trending, reports itself, but when he generates the reports, it will not be up to date because we are looking for 10 numbers out of 1,000 and over the period of 3 months. When the reports is generated, maybe 6 months down the road. So how does ranking component works itself? By adding a queries to the BMS systems itself, it will automatically compute and the results will be out immediately. Top open valve greater than 90% by hours. The last 3 months, this is hours. FCU number 3, it opens more than 2,000 hours. So you're wasting a lot of energy based on you will know that your fan coil is wasting a lot of energy based on these reports itself. So your technicians itself will rectify all these 10 numbers concerned immediately, not doing routine servicing. If I'm doing routine servicing, today is 1 to 10, I will take care of number 3. But what about 598? That will be months later when I check on this fan coil. We also can do reports itself for ranking components itself. If let's say we base on set points, the temperature set points and your actual readings of temperature itself, what is the deviations? So we can range from that to have the least, the furthest away from the deviations from the temperature set points. That is where we monitor or we rectify the problem first. This will be proactive of technicians and engineers to check and extend the lifespans of their equipment. We also believe in training. Why do I say that? Owners itself spend tens and hundreds of thousands of dollars on BMS systems, but how many engineers do they really understand how to operate a BMS system in their building? Most of the engineers and technicians adjust basically just time schedule, change of set points, complaints, too hot, too cold, manual override the valve actuators, trending, basically it. From my experience itself, technicians and engineers learn the system through try and error. Right. There's an OEM manuals, yes, but it's not everything that consists of the features and the knowledge of the BMS system that they has. Therefore, I strongly encourage owners itself to learn so that they have the power to control what, where, and how you want on the BMS systems. This will extend the lifespans of their equipment and resolve operation costs and have a green building. I'm talking about BedNet now, alright? So this is a typical third-party BedNet systems, and there's 3 types of profile. Do you all know BedNet profile? Have anyone heard of BedNet profile before for controllers? Alright, it's okay. Later my colleague Ian itself will explain on that. So for BedNet system itself, why do we need a BedNet compared to proprietary system? Because we want to protect end user itself. If you are having a proprietary systems, you can't go to anyone else but that particular brand. So with the BedNet system itself, 3 years, 10 years down the road, if the building owner doesn't like the service or the quality of the products itself, he has a choice to change. Alright. So example, now I have a new AHU to be installed. I can go back to this brand, or I can get any brand of BedNet controllers to be installed to the current system. So this is BBC. So as a building owner itself, I want this particular DDC controllers to communicate with this DDC controller that is certified under BAAC profile. I'm not able to retrieve data. I'm not able to do scheduling. I'm not able to do trend data collections from this particular controller. But if I'm connecting to this DDC profile, BBC, I'm able to retrieve data, share scheduling or override scheduling, trending, data collections can be shared. As I mentioned itself, DN itself will talk more on the profile. And if the controller is faulty, the owner itself has the right to change the controllers to any brand that is BTL certified. This is BACnet itself. What about proprietary? Third-party proprietary systems itself, there's two options for end user end of the day. First option itself, if today one of the controllers fails, you will get a code, a request for a code from the BMS contractors itself. If it's obsolete, the contractors will say that, sorry, I can't provide you with the quotations. So what can the owner do? The owner only have one choice now to replace the whole BMS system. Worldwide, everybody will be the same for this. So there's another options the client face will have. Today it failed to get a code for the BMS vendor, and we straight away replace it with a DDC controller that is able to communicate with a proprietary BMS system. And we need to upgrade the computers and the firmware and the gateway itself. This is 100% backward compatibility and return of investment. So, right, so I will end my presentation here. Anybody have any questions on this topics itself? Sorry?
The checklist you showed before?
Yes, IFDD.
You have to write them, right?
I have.
That has to be written manually, right? Somebody has to.
Yes, yes, of course. Because the thing is that somebody had to write manuals. Not manuals, rules.
Yeah.
Somebody had to write rules itself, and right. So rules are written. All right. So the building BMS companies itself will talk to consultants and understands from the building owners which equipment or what equipment is going to be installed in this building, whether it's commercials, industrials, what are equipment, and what is critical for him to be monitored itself. So we can write rules based on his needs and followed by the checklist itself. So there will be communications between all three parties itself. And this will not be fixed because once the building loads increase or 100%, with the equipment, with the occupants itself coming in, building behave differently. So once building behave differently, we will change the rules, or we don't say change, we edit the rules and we edit the checklist itself to optimize. Yes, sir?
Presentation. Where you also the warranty period and the lifespan of the lifetime.
Sorry?
Warranty period and the lifespan of the lifetime.
Warranty period of which system? Of the BMS? Okay, that is a good question, but that varies itself based on which service provider you are looking at itself. But for my company, as you know itself, I'm from Reliable Controls. My product is a 5 years warranty. The lifespan itself, currently I'm established in 1986. I'm 33 years old now. In America and Canada, I do have DDC controllers in a mechanical room that is still running now. So you're talking about lifespan, 33 years. Maybe older as some of the engineers here. Any other questions? No. Right? Yep, so I'm out here. Yes. Escape.
Thank you very much for your time. I'm going to continue on a little bit from where Jacob left off. As Jacob mentioned, he spoke a lot about, sorry, I'll get back into these. He spoke a lot about bringing systems together and integrating different types of systems. So this afternoon we're going to just have a talk about a protocol that's purpose-built for building automation control networks called BACnet. Now, BACnet is an ASHRAE ANSI 135 standard and also an ISO 16484-5 worldwide standard. Jacob mentioned in his presentation about proprietary protocols. And proprietary protocols are particularly owned by an individual or by an organisation. And therefore, it is up to the individual or that organisation to expand that protocol. Open protocols, on the other hand, are not owned by a single person or an entity. And they are typically in the open forum, which means the advancement of those open protocols to the benefit of the end users is open for discussion. And so how BACnet actually came about was that, as you remember from Jacob's presentation, we started with pneumatic systems, we then which gave way to electronic systems, which then gave way to smarter DDC systems, and now we're in full intelligent systems. But as we went through the 80s and proprietary systems were generated, vendors actually built their own communications protocol, which means that if we can't communicate, we can't share information. Okay? So what happened was, when we had proprietary protocols, the balance of power was actually in the hands of the vendor, not so much in the people who actually put their hands in their pocket for the system. So it was actually the proprietary system that may have driven or forced the owner of a system to expand his system. So in 1987, a committee by the name of SSPC 135 gathered to start to generate a common language or a set of rules by which we communicate. Much like any rules of communication, if you ask me a question, I stop and I listen, and hopefully I can answer that question when you've finished. It's the rules that which exchange the information. So as from 1995, the standard was picked up by ANSI, and then there were many public meetings about the development and future expansion of the protocol. Then in 2003, it became a published standard from ANSI, and in 2003 it also became an ISO standard. So the BACnet philosophy is about building a protocol that is to the benefit of the end user. It is actually driven along by volunteer working groups, so there's no money exchanged to develop the BACnet protocol, and it's these working groups that are voluntary that actually advance the standard and pass it on. And the idea of BACnet is about building blocks, about simple building blocks that are made up of devices, objects, properties, services and networks. Much like a car that's disassembled in nuts and bolts on the ground, it serves no purpose. But if you bolt them together well, you now have a vehicle that's been bolted together that can serve a wonderful purpose. So with that in mind, we'll just start simply with the BACnet device. Okay? And the purpose of a device is to transport information. Okay? So the device, its existence is a logical node or a device that will reside on a BACnet network. And this is a typical device that if you're involved in BMS or mechanical systems, you probably have seen many devices that reside on a network. A device is actually identified by a composite three-piece number. And the first part of that device is what we call the device instance. And the device instance can be anywhere between 0 to 4,194,302, which means that BACnet has been purpose-built for a very large system. A device on a logical network must serve information out. So that information is what we call an object that lives inside of our controller, or inside of our device. And object is a set of information or a particular sensor. So if we go back to our VAV controller that I mentioned just before, an object to a VAV device would be the temperature sensor. So the temperature sensor lives in the device. And here's our example. And typically, how we actually determine or define our object types are by the service that they provide. So typically in a BMS system, we have analog inputs, we have analog outputs, binary inputs, and binary outputs. And as the standard has progressed over time, it no longer just has objects for HVAC services, it also has objects for life safety, for security system, for lighting systems. And so the standard at the moment currently allows for over 50 different objects. Excuse me. Now the object type, we don't want to send that piece of information out from that device as a whole word. So we provide a mnemonic. So now an analog input becomes an AI, an analog output now becomes an AO, and etc. So in this particular case, if we go back to our temperature sensor, okay, we spoke about the object living inside the device, and in this particular case, the device is number 1000. The object type is an analog input, and it's the 12th analog input. So that object is 1000 AI12. Okay, oh, there it is. So an object, now, we know that it's an analog input. So the object must, I'm sorry, I'm behind a little bit here. The object, we need to know information about it, that it is just not an analog input, because an analog input is any signal that continuously changes, as opposed to a binary input, or a binary point, which is either on or off. So we need to tell the system, or the specification actually defines how the properties define that analog input. So in the standard, it allows some basic applications to that. So the properties in this particular case are the object names, the present value, the status, and the units. So if we go back to our temperature sensor, the object name may be room 1000. The present value would probably be 24.2 degrees. The units would be degrees C, and the status flag will be in operation. The standard also allows for further properties to be added according to the needs to get that piece of information out. And the standard actually defines property numbers to each of those property values. So, just from the ground up to go refresh through your crash course in BACnet, is that a property defines an object. An object lives inside a host controller, and a host controller resides on a network. And the primary purpose of that host controller is to get that piece of information, that object, out to another device or multiple devices on that network. So the way that we do that is typically through physical links, which is the different types of data links that we have. BACnet standard has typically 4 different types of links. IP, to get information out onto the internet. Ethernet, which is a fast, short network. MSTP, which is a longer range, more cost-effective network. And point-to-point, which is typically just between 2 devices. So now's a good time to go back to our host controller and how we identify that. Because we started with, mentioned that it's made up of a 3-part composite number. The first is the object instance that we touched on. The second is, if you remember, can have a range of 0 to 4,194,302 controllers. So we generate networks so that we can go and find the particular controller that we're having. And the last point of that device identification is that we tell it, we have to have it as a unique address on that network. Now, because we get through different types of networks, and IP or Ethernet is a totally different electrical signal to MSTP or point-to-point, we have the standard allows for routers to change that electrical signal to a signal on another network, which ensures that the standard caters for different networks. And the standard actually is a communication model where I ask a question and I have an answer to that question. So a client will ask a question and a server will answer that question. And these are typical types of services. So a read property or a multiple read property where I can ask a question of another controller. I might say, what's your temperature? And a single read property, it will tell me the temperature. Or I may ask a VAV with a multiple request of what's your temperature sensor, your damper position and your airflow. And the device that I've asked a question will answer. So the BACnet testing laboratories, as Jacob touched on, is an independent policeman that's responsible for the testing and the authentication of BACnet devices. These are the profiles, because not all controllers are created equal. These are the different profiles that are available in BACnet. These are the three operator interfaces. These are the controllers. Expand on the controllers a little bit, as Jacob touched on. From your right-hand side, we have simple smart sensors and simple smart actuators on this side. And as you can see, they only have a few BACnet properties or services to share. Then as we move across to your left, we move into the application services. And the application services you'll see in that red bar there, they start to increase in their services capabilities. And then across again to the next one, the application, advanced application server, even greater services available, and particular, they have scheduling in there. And then if we move across to the BACnet building controller, which is the highest profile of services provided, which means that it gives us the greatest amount of information exchange between devices. And then finally, these are devices that are profiles that allow us to communicate across multiple networks. So the BACnet testing laboratories come along, and because BACnet is an open protocol that's designed to the benefit of the end user, anybody can actually gain the BACnet protocol. Anybody can generate a BACnet device according to the profile that they want. They then submit it to BACnet. BACnet will test it. If it meets the minimum requirements of that profile, then they will work on their protocol implementation conformance statement, which goes back to the objects that we spoke about a little bit earlier, the properties, the data links and the sharing. Also, as part of the PIC statement, we need to be able to inform the services that are available, how we communicate, the rules on exchanging information. And that is done through the BACnet interoperability building blocks, which is the services. Do I have the rights to ask you a question? And do you have the capabilities of answering my question when I ask? So this is a typical BIP. The interoperability area is data sharing. The service provided it is a read property multiple, and in this case it has an A, so it's a client. Once BACnet tests and it's been accepted, BACnet will then publish on their website, which is a public website, the profile, the pics and the bibs of the device. Which means if anybody comes along and says, I have a BACnet device, you as an engineer or as a person interested can actually hit this public website and go and search that controller and see if it delivers to what they say. See if it's been tested by BACnet, because BACnet testing laboratories are the policemen that ensure that when people provide these devices, they actually live up to what they're doing. Because we're trying to exchange information. They're the rules about exchanging information. So BACnet is an open protocol that's designed to the benefit of the end user. It is developed by BACnet, it's pushed along by ASHRAE, and it's policed by the BACnet testing laboratories, which enable us to take information from a security system, as Jacob's displayed, through to a lighting system, through to an air conditioning system, because it's the rules on which we exchange information. BACnet, because it's in the public domain, is an impartial protocol that is future-proof and backwards compatible. So we ask that the industry prepare and plan for an open protocol such as BACnet, which means we ask that if you're an engineer, a consultant, or a contractor, we ask that you have BTL or request the BTL listing, and that way you can check on the specifications of the PIPs and the BIGs. Oh wow! And make sure they're relevant, and also make sure that the provider of that device is accountable, that they're there at the end of the job when we actually connect the wires, and that we can exchange the information. We believe that BACnet will give the end user, the people who pay for these systems, a level of peace of mind, because it's backwards compatible and future-proof. We'd like to think that the consulting fraternity will specify this, because it looks after their customer, the end user. We also think that because it will provide longevity, it has a great return on investment for the owners and the operators of these buildings. So BACnet is an open protocol that has been pushed along by the industry body at no benefit to them in a profit sense, and we believe it's to the benefit of the end users, and that's BACnet. I hope you enjoyed that. Are there any questions on that? No questions on BACnet? Then what I'd like to do just quickly, that as we are working on... Oh, thank you. Since we are now talking about an open protocol that actually connects multiple systems or services within a building, access control, lighting, life safety, building automation, we now are faced with an issue that people like us, so people who provide service to these systems, people who interact with these systems, tenants, operators, typically want to gain access to that system in a convenient way, which will typically be from the place they are, via their iPad, via their mobile phone. So now we are exposing our BMS systems to the World Wide Web. So what does that mean? Well, as building automation systems are responsible or play a key part in the benefit to the largest assets of a building, those being the people within those and the plant and equipment within that building, we are now at a place where we are now looking after IT systems, or there's a convergence of BMS systems and IT systems. So with this convergence of IT systems and BMS, we now need to start thinking, okay, we now have to start applying IT type standards to these BMS systems. In 2015, IBM conducted a survey in the States of building automation systems, and they found that 84% of BMS systems that were connected to the internet were not protected at all. Only 29% of BMS systems had any sort of security or were in the process of having security looked into for that BMS system. So why is that a concern? It's a concern because many different types of people connect into BMS systems, okay? And whether they're voluntary or involuntary, they will have access to information on that system. And they can get in to change environmental conditions, which may upset an experiment or ruin plant equipment. They may turn equipment on and off. They may change schedules so that the people in that building lose their conditions. Case in point, in 2011 in Houston, a wastewater treatment plant was hacked because it was connected to the internet and it had a 3-character password. Another case in point, in Finland, there was a BMS system that actually looked after the heating plant for across 2 buildings. That particular BMS system had a DDoS attack. That DDoS attack blocked a controller. That controller started to send out strange alarms. The company that was looking into that could not access the system from offsite. They had to send a technician to the site. That technician had to change a controller, a piece of hardware, and get the system back online. That attack pulled that system down for over 2 days, and it turned the hot water plant on and off continuously, possibly damaging that plant. In 2013, Google in Australia asked a cybersecurity company to penetrate test their BMS system. That cybersecurity company was able to get into user passwords, able to get into schedules, able to get into configuration of controllers and files. A very dangerous, deep part of a system for people who know what they're doing and also for people who don't know what they're doing. That company then went away, searched the web and found 20,000 other cases of the exact same penetration. Shodan is a search engine on the internet that is used to sniff open ports through firewalls connected to the internet. Shodan has identified today over 30,000 BMS systems connected to the internet with no security. This led America to open up this department in their Homeland Security, because between 2011 to 2014, attacks on BMS systems increased by 74%. In 2017, there were over 1,000 attacks on BMS systems reported to this Homeland Security Department. So who's responsible for the security? Well, I would argue anybody who's connected with building automation systems. Owners, vendors, contractors, and consultants. We're all responsible to play our part in this. And pleasingly, ASHRAE, through BACnet, have also jumped in and are playing their part to address this very sensitive issue. So how do we actually increase our security of our BMS systems? Well, as we mentioned, our security systems, our BMS systems are typically coming in line with IT. So we'd ask everybody to actually apply typical IT rules, ask for hardening rules and guidelines to be put into BMS systems, and make sure that they're audited. We'd ask that the information be made is confidential. We ask that the integrity of the system remains strong, so that nobody can get in, copy information or damage information. And we ask that it be made available. As we spoke about before, people want to access their systems from their mobile devices. So it needs to be made robust. It needs to be, that connection needs to be reliable, and that connection needs to provide confidence and integrity. We need to design our systems well in line with IT systems. So we ask for vendor hardening. We ask for dedicated networks. We ask for information transferred around those networks to be encrypted. We ask that companies actually build contingency plans and re-establishment plans for their systems. We ask that authentication actually be implemented, meaning that we disable public access. We disable, when we walk away from a job, we disable the default passwords onto a system. We ask that user credentials are actually unique to the individual, and it only allows them access to the area in the BMS that they're actually trained to be in, and they know what they're doing. We ask for a password management system. Again, this is standard IT practices. That password management system be implemented. And then everybody likes a cup of tea and likes to go home at the end of the night. So we ask that auto sign-off becomes part of our standards. We ask that you protect the machines. Update, again, vendor hardening is very important. Ensure your software at server level is updated, and make sure that there's a maintenance system about ensuring that that software maintenance operating system is kept up to date. So, over the years, as Shodan has presented us, 30,000 systems currently exposed to the internet. That was typically from the outside in, punching a hole in the firewall via port forwarding. Once inside a building, typically you could get to probably to other buildings quite easily, again through punching holes from the outside in to firewalls. What BACnet has actually done and delivered or started talking about in 2016 was Addendum BJ, which has been incorporated into the standard SSPC 135 in 2018. And what this is, it provides what we call Secure Connect. And Secure Connect is, it delivers and defines a BACnet link. And that BACnet link is in line with IT standards. It also uses a physical layer through web sockets and uses a TLS, Transport Layer Security, to ensure that that data is exchanged with the right place. And we ask that it also defines that it goes over a virtual private network. So how BACnet Secure Connect works or operates is that it generates connections from inside the building to a secure location, generating a hub and spoke type situation, which means that users now come from the outside instead of going straight to the building and punching a hole from inside. Punching a hole from outside through the firewall. They also connect to BACnet Secure Connect, and that connection, once it's made from the inside out, is a secure link which becomes bi-directional. So BACnet now provides a safe transport of information because people want their information from wherever they are. It encrypts the data, it provides for dynamic IP addresses, there's no firewall penetration, so IT companies aren't upset anymore. The data is secured and transported securely over a virtual private network. So in short, why is this important? Because people are connecting to systems all over the world from outside the buildings. And right now there's 30,000 buildings exposed. Who's responsible? I think we're all responsible. And how? Well, BACnet has actually provided a solution through BACnet Secure Connect. And so that you don't think I made all of that up, this is a list of references that we've actually generated this through. And that's what we'd like to tell you about secure connecting for building automation systems. And I thank you for your time. Has anybody got any questions about that? No questions? All right, thank you for your time. There's a question. Yes, go on. What have you got?
This
part basically, most of the time in the early management system, we share the one local area network between BMS and maybe with other systems as well. Sometimes, for the, let's say for extra low voltage system, we might use one network.
Yep.
One same local area network.
Yep.
So that we'll have one firewall and other component for the security. So by adding the security part to the controllers, to the controller level, will you add some unnecessary cost factor to the price so that the final price will go up rather than delegating it to another side of the local area network?
Well, at the moment, there's systems around that are actually using virtual private networks to get out, and they're fine. They're great, and a virtual private network enables a connection across the World Wide Web that is secured. We're using that, yeah. Or BACnet's suggesting to use that, but the added benefit is that BACnet Secure Connect will also encrypt the data. So now we're encrypting the data, which then goes on the virtual private network, and it adds another layer of security. So we're securing the data as well as putting it across a secure network.
You said that few hacking were happened in various countries before.
Yep.
You mean how they gone to controller level, like let's say you had the BMS running on BACnet even with BACnet network.
BACnet, yeah, there's some.
They have gone into that level.
Yeah, the BACnet standard has a port forward that is the BACnet port, 84808.
So if I ask like BACnet MSTP or RS485, still people have the network.
People can still get in because it's an open port. So if a BACnet system is left, if the standard port's left open, Shodan or can sniff around and find that open port, because that's the port. Like Shodan will actually go and find any sort of open port on the internet. But if you type in BACnet, it's looking for that actual port number. So yes, there are BACnet systems that are being hacked. But that's part of the reason why ASHRAE got involved and said, okay, we need to put forward a solution within the standard so that we all understand how that information's passed around, and they came up with this, which is primarily you're hitting from the. If we go back, the important part is that it's a connection from inside the building through the firewall out, and typically IT people aren't upset about that because you could probably walk into any of your buildings here, unless it's a high security building, and you could probably go to your computer, open up your web browser and search something because you're coming from inside your building through the company's firewall to outside. That's not a security risk. It's when somebody's outside trying to come in is the open firewall and the possible danger. Yes, sir.
Where is that particular middle part is posted? Yeah, it's okay. Where is that posted right now?
So with that can be hosted in a cloud server or a physical server on a. Jacob will try and connect us. So that can be in a cloud server. It can be on a hard-coded machine, but it typically should be off-site because you want the controller to actually come from inside the building out through their firewall to make that initial secure connection to that server. We suggest, in Jacob's and my experience, we suggest that should probably be on something like Azure, okay, because some of the solutions around at the moment will only take quarter of a core, and that quarter of a core can be as little as $18 a month. And Azure will probably guarantee that server be up and online 99.995% of the time. So it means that the connection's always available and it's very secure. As opposed to if you have a server in somebody's premises you've got the issue of the line to that server, and then also you've got the cost of constantly updating that server and keeping it up to date. So in this example that Jacob's put up for us, you can see that the communications is running from inside the controller, there it goes, inside the controller down the bottom, out through the World Wide Web, through the firewall to remote access. So remote access could live inside a building. If you've got a campus style, it could live inside one building, or it could live outside the campus. Here's the typical installation of it, which is out in the world somewhere in a cloud, and the controllers are connecting out. Because the controllers are connecting out, when the workstation there connects to RC Remote, connects to BACnet Secure Connect, it's actually then makes its connection, it's checked to make sure that it's an authentic device to be on that network, and then it will be able to, once that connection is authenticated, it can then connect through that secure connection that's come from inside out. Yes, sir.
Yeah.
Oh, sorry.
So practically, there must be like, see, you have a subscription over there, right? To the central connection, you have a subscription.
Yes.
Yeah. So someone might say like, practically, it will be beneficial to have a firewall which has much more security than putting all the data into a central point.
Quite possibly. One of the things that, in my experience with firewalls, is that IT people who are working for the building, they're the ones that want to control the firewalls. They're the ones that want to control what comes in and comes out of a building, and they're the ones that have always said to me as a contractor, in my contracting days, you'll have nothing to do with the IT system. I'll give you a port. So it's typically, as far as BMS world is concerned, it's typically the firewalls being provided by the actual company that owns the building. Yes, sir.
For your presentation first, and my question is also from the cybersecurity side. So, in case if your system is hacked by somebody else from the outside, so do you have any mechanism, engineering mechanism to log into the system and recover it back? Because the person who hacked the system might be close all the ports and might be change the password and everything inside. So do you have any mechanism to log into the system and get it?
Okay. So the way that this has been implemented is that to access that system, you must know the IP address of where you're going. You must know the port. You must know the name of the virtual private network. You also must have an authentication certificate on your PC that is registered at the R. So there's multiple levels that need to be addressed before you can even get close. So with BACnet Secure Connect, because you've got that 256-bit encryption and authentication certificate that can go up to 2048 bits, that would take a very, very, very long time for even a supercomputer to crack.
Sorry, but I'm asking is the BACnet platform, is there any ports for maintenance, secured,
Is there maintenance at the BACnet level? There should be maintenance at the BACnet level, and so the standard will constantly develop. If something has been identified by that working group, so if the public comes or owners of buildings come along and say, hey, listen, we've been able to find a way to penetrate that, then ASHRAE and BACnet will address that. And then also, as part of my presentation, it's not solely the responsibility of BACnet. Like we as people who are connecting to the world, we need to make sure we do our vendor hardening. We need to make sure that passwords are updated. We need to make sure that we're doing our part on an IT level, because BACnet is just the way that we're actually communicating information. There's still a very large IT component to just making some basic rules and ensuring those rules are adhered to about securing systems. Thank you. Oh, if there's no other questions, we've just are we able to run a small YouTube example of how this might be secured?
Can I ask one?
Oh, sure. Sorry.
It's not about the discussion we had today. Something about the IoT-based BMS system. So, in case. So, as an international service provider, do you suggest for IoT-based technology the next time to come? Because as it seems, there's a trend for IoT-based systems, not only BMS systems. As an international service provider, do you suggest, or how do you think the difficulty of applicability such system for times to come?
Have you got an answer for that?
Can you repeat again?
If I understand your question, what's the advancement of
The IoT.
IT? So that was
It's about IoT-based technology.
Yes, correct.
So, how do you think the applicability of that for future metrics like
For future generation.
yeah, because people in the current condition, like you have some kind of detectors and so
Yeah, sensors.
sensors.
Yeah.
Then we have IoT machines.
Yes.
So the people set the challenge like maybe it will be the advancement, but the people who people accept them. So how do you think this is the digital?
Okay, currently IoT itself, there's no really a standard itself. Alright, so a lot of my peers itself mentioning that they are IoT based, but there's no regulations in place or specification itself. Everybody say that I can put my stuff on the net for users to access, but what about security? You know, when everybody access to it, nobody knows what standard it is. So just like BMS itself, it took so many years to come out with the standard, and we got ISO standard itself to approval itself. So I don't say that IoT will not take off, but the thing is that there's no really government bodies to regulate the specifications of IoT. You know, it's just like cloud-based. Today you put out a lot of things, maybe tomorrow we're on the news, Hollywood celebrities itself, everything is being hacked. Cloud-based, that's IoT, anybody can hack. So to us itself, for rebel controls, our standpoint is basically we still believe now the open protocol to protect end user is still BACnet protocol. We are not saying that it won't be IoT, but for now itself it's still BACnet.
You have tried with the IoT software.
We can put our stuff on the IoT, no issue on that. But the thing is, at the end of the day, what is the regulations or specifications for all the peers itself are able to communicate between us? There isn't anything.
Yes, sorry, last one. CAL368 is guys login permission, and if you by the can you take what that means. CAL368.
Can we, if you don't mind, can we play on YouTube to talk about the service? Oh, you have one question? Yeah, sure.
That self-protection, like self-protection, light protection,
Search protection.
Yes.
Alright. Because this is Untitled, I cannot reach.
Yeah, I'll hold that.
Yeah, that's it.
BACnet system, the building management system. So what is the protection way of the service for the language?
For lighting itself, because this is search arrestor itself on the network itself, you know. That all depends on where you want our more. You can put on IP, MSTP, even our one processor as well. For lighting.
Alright? Okay. So we do have a YouTube itself, talking about cybersecurity itself. We just want to share this with you guys.
What do you see?
Here for you.
Maybe a building system keeping you comfortable. That's what most people see. Some people, however, see something completely different. They see security holes waiting to be exploited. They see access to an entire building system. They see opportunity. They see control. They see chaos. What do you see now? You wouldn't accept these vulnerabilities in your normal network. Then why would you accept them in your backnet network? Now, confidently safeguard your entire building management system from unauthorized access with RC Remote Access. Deploying RC Remote Access on your existing network is easy. Install RC Remote Access on your local or hosted server. Set up your security certificates. Create a backnet VPN. Configure the backnet VPN clients by entering a server IP address, BVPN name, and password. That's it. You're done. Everything is now secure and connected and easily managed through RC Remote Access. Your network is only as strong as your encryption. With RC Remote Access, every one of your communications are secured with 256-bit encryption. This is the same high security standard used by banks, militaries, and your most trusted institutions to ensure no unauthorized third party is able to read or tamper with your data. These connections are encrypted using TLS and further secured using up to 2048-bit server certificates. Use this enhanced security to confidently expand your network and add backnet clients on the fly with no downtime. Scale RC Remote Access from one system to multiple buildings to entire regions. Simple, secure, scalable. The backnet virtual private network you can rely on. RC Remote Access. Stay secure.
All right. Any questions you want to ask? Right. So, no questions, then we end our presentations.
In Sri Lanka, we have
Yes, sorry.
In Sri Lanka, they have been using CBUS. Then,
This is the update
how is
you've
it,
been waiting. We took your feedback and
Sorry,
our
sorry.
body weight kept.
Sorry.
in Sri Lanka, we have been using CBUS. CBUS, yeah, for building in Sri Lanka. So,
So there is communication.
how will it be
How will it be?
how will it be differentiated with this backend?
CBUS is a proprietary network.
Right?
It's a proprietary network.
Yes.
Yes. So it's for my peers, you know, that they develop a CBUS communication itself. So just like my earlier presentation slides itself, if let's say you are the end user, you are so-called being tied down like that. You have no choice. If let's say today one of the controller fails, you need to get back to them. So if let's say you want to upgrade firmware features itself, you have to get back to them. You have no choice unless you replace the whole system for you. Yep, that's it. But for reliable controls itself, as I mentioned earlier, I'm 33 years old now. I still have controllers that is proprietary. Because in 1986 itself, there wasn't really backnet during that time. So it's proprietary. I still have those controllers in America and Canada that is still functioning online, controlling mechanicals, AHU, chillers itself. So that is also proprietary. But reliable controls, we do it differently. Because one of my controllers here, proprietary controllers, I can change it to a backnet controller. Reliable controls, backnet controllers, and it can communicate on the same network itself with the proprietary controllers. But with the CBUS itself, I can't really help you on that because you are stuck with them. So if I say touch wood today your controllers fail, they can quote you any dollars you have to buy from them. So. Any questions? Any other questions on the floor?
Thank you very much for coming along. We appreciate you giving up your night time, so thanks for coming. I hope our language was clear and concise. And if you do have any other questions, please, Jacob and I will be around for a little while. I'm happy to answer them.
You can let us know if you have any concerns or get to know more about products. Do let us know. Thank you.
Thank you.
Thank you.
Good evening. BMS, one of the vast spreading field in the engineering industry, and with the sustainability concepts comes into the picture. Every building has been gone through with this building automation systems to improve the building efficiency. So today we have given these two technical expertise, these two gentlemen as two genius technical expertise. They have given insights into how BMS is effective on the buildings, as well as what are the protocols that we are using. The open protocol, which is most known as the backnet protocol. And thanks for being here, being educated us, and being sharing your opinions and sharing your knowledge with us, as most of the industry experts are here in Sri Lanka. So I would like to again thank Mr. Jacob Sang and Mr. Ian Giles for being here, spending their valuable time and educate us, sharing their opinions and knowledge with us effectively. Then also I would like to take this moment to gratitude Mr. Prasanna Narangoda, past president of Building Service Engineers Sectional Committee, and Mr. Chandana from Luminex Private Limited for introducing these two technical expertise to ISL and make this session a successful session. So it's time to present the token of appreciation on behalf of ISL as well as Building Service Engineers Sectional Committee. For that, I would like to invite Engineer Mr. Samantha Gunawardana, past president of Building Service Engineers Sectional Committee, to be on stage to present the token of appreciation. And also I would like to invite Mr. Jacob and Mr. Ian Giles, please be on stage.
Thank you so much.
Thank you, Engineer Samantha Gunawardana. So, in order to wrap up the session, I would again like to give my thanks on behalf of Building Service Engineers Sectional Committee to ISL staff to giving support for us to conduct this kind of important session. And also I would like to again thank for the audience, the keen audience who have been here and make it a successful session. Again, I would like to thank these two gentlemen again for being here, and let's wrap up this session and have a safe journey on your way home.